Hello all, today we are solving LeetCode problem number 85, maximal rectangle. So we are given an n cross m binary matrix. So binary means we have only 1 and zeros present within the matrix, right? And we are asked to return the area of largest rectangle with all ones. So if you can carefully consider the first example, we have to return the largest area of the rectangle with all ones. So this particular rectangle is the largest area rectangle with all ones, for which the output is 6, which means the area is 6 and we are returning 6 as the output. So how do we solve this problem? So for finding area, we need height and width. So height cross width will be the area of rectangle. So how do we find height? So let me choose the other color. So height. So if you see in this first example, we could find or we could process the height row by row. For example, we can consider this as a coordinate, and we can form a histogram by using this first row. So the histogram will be this 1 and 1, and this will be 0. So we are getting a histogram of, and this is the histogram formed in the row 1, right? So because of that, we have row 1 as 1 0 1 0 0, right? And similarly for row 2, I'm sorry, this should be row 1, this should be row 0, because we are following the indexing, right? 0 indexing. So because of that, so in this case the histogram becomes, here this becomes 2, and even this becomes 2, this becomes 1, and this becomes 1. So that histogram becomes, let me draw that separately for understanding. So this becomes the histogram, right? So how do we represent this? So we represent this by row 1 is equal to 2 0 2 1 and 1. So this is how we process each row, and we determine height, right? So so we can define that each row be a matrix named, the array named height, right? So we can have height of I. So this will be height of I, and this can be also height of I, and every element present within that can be height of I, right? So height of I can be the number of consecutive ones uh, in the particular current row, right? So how can we bring this programmatically? So we can have this as, we can iterate through the row, and if the row of j is 1, we increment in the height uh, array, right? So height of I, oh, so this is j, so height of j becomes, we have to increment that by 1, right? So 1, right? If not, that will be 0. So this is the observation, and now we have to find width. So let us consider this example because the first example is very big. So let us consider the second example to solve this. So by this we are having height as for height 1 will be 1 1 0 1 0, and for it will be 0. So 1 will be 2 2 0 2 1, and h2 will be 3 3 1 3 2, right? So now let us go for width. So solving width will not be similar to height. We cannot solve width by consecutive ones. Why? Because width will be very different, because if you clearly see here, uh, we can run through this only. So if you clearly see here, this is the height when at row 2, and width will be 1 for this, and it becomes 0 for this, right? So the width resets to 0 based on two condition actually. So width resets to 0 when the neighbor's height differs actually. So the neighbor meaning the left and right, if the height varies, if the height is less than the neighbor's height, it resets back to 0, or we can write it as resets to 0 based on neighbor's height. So how do we solve this? So instead of finding the width, we can use alternative. We can traverse from left and traverse from right. So using left, we can determine the start, and using right, we can determine the stop. And when stop minus start would give the width at the index position j or I or whatever, right? So here we can have it as left of I is the nearest position from the left where the rectangle starts, right? And right of I is the nearest position, or nearest position where the rectangle stop, right? So using this we can calculate width, right? So let us understand this. How are we finding the left of I and right of I respectively? So for this, let us consider this particular row only, because anyway for height and width we are processing them by row, right? So we have 1 1 0 1. Oops, 1 1 0 1 1, right? So based on this we are calculating left. So we have left equal to an index. Oops, it's not an index, it's an array, my bad. So we have the starting position, so current left, to track what exactly is the nearest starting position. So this will be 0 for left, because the leftmost index, which is, it starts from 0, right? So that will be 0. So this is the array to store the left of i's here. So this will be of size n, and this will be initially initiated by current left, which is 0. So this will be 0 0 0 0, right? So yeah, so now we can see that at index 0 we have 1, and hence the left of I, which is left of 0, will be um, 0. Why? Because we start as at current position 0, and it is 1, which means we can proceed further, right? So the width can expand this way. So because of that, we are not changing the current position, because we need to have we need to track down the starting position, so that to find the width, right? So because of that, this will be 0, and in position 1, this will be again 1, the value will be again 1. So left of 1 will also be 0, right? And now there comes the change, because at position index position 2, this becomes 0, and left of 2 will be 0 0 only, but the current left will be changed, because the current left was first initially in the index position 0, and now because 0 appeared, this should be reset, and this will jump to the index position 3. So current left will be updated by the current position I plus 1, which is 3. So current left will be 3, because the next position at where the rectangle starts will be the current left. So at index position 3, this will be 1, and left of 3 will be 3. And similarly at position 4, 1, and left of 4 will be 3. So the left array becomes 0 0 0 3 3. Okay, so in case of right, so right, this also will be of size n, and the current right will be n, because we need to find the stop position of the rectangle, right? So because of that, this will be initialized with the nth value, which is here the n value is 3 5, right? So 5 respectively. So you have 1 1 0 1 1, and here we are finding the nearest stop position. So we iterate from the backwards. So first, for the position, this is 4, here the value is 1, and the right of 4 will be 5 only, and the next position for 3, this is 1, and right of 3 will be 5. And now for index position 2, this is 0, so that is where the rectangle stops, and because of that, this position will be anyway, this will be 5, but the current right will be updated to the current index, which is 2, right? So in next, the first index, it is 1, and right of 1 will be 2, right? And here similarly, right of 0 becomes 2. So the right array becomes 2 2 5 5 5, right? So we have to come up with the observation here. So what is the observation we are coming up here, right? So from this we can say that the value changes where does this current left get updated? So this, if you clearly see that if we are anyway processing by row, right? So if the row of I is equal to 1, right? So the left of I will be we have to find between it should be maximum of current left and the left value left of I, which is the initialized value, which is 0, right? So this will be the observation here. And else, when how are we updating this current left? I said I plus 1, right? So based on that, if not, it will be the left of I, that will become the current left value, which is 0, and current left becomes I plus 1. So this is the observation here. And in this case, if row of I is equal to 1, here right of I become minimum of current right and right of I, because here we are initialized with the n value here, so we have to have the minimum of it. And else the right of I becomes n and current right is becomes 1, sorry, I, right? So this is the observation here, which we will be using them for coding. And now how are we finding area? So as I said, area of width will be right minus left. So width of I will be right of I minus left of I, right? So and area will be height of I multiplied by width of I, right? So here we have already calculated height. So the height is 22021. So 22021 multiplied by width. So we have right as 2 and remaining it's 5 5 5, right? And left as 00033. Yeah, it is 000, and this is 3 3. So here you get 2 cross 2 4, and this will be 4, this will be 0, and this will be 4, yeah, and this will be 2. So the maximum among all this is 4. So here we are getting the area as 4. So if we repeatedly find for the complete array, the entire array, we process each and every row, we will end up in 6 as the output. So this is how we have to solve. So with all these observation, let us go ahead and code. So for this problem, the time complexity will be big O of n cross m because of the size of the matrix, and the space complexity will be order of n because we are using the arrays for height and storing the left and right. So because of that, this will be order of big O of n. And yeah, let us go ahead and code it up. So first the base case, so if not matrix return 0, right? And now we need to have we need to find the size of the column. So n is equal to len of matrix of 0, right? And we need to create the height array and create and initialize the left and right array as well. So yeah, so now we are processing by each row by row. So for row in matrix, and we have to assign the current left and current right. So this will be 0 and this will be n, right? So first process height, right? So we have to iterate for j in range n, column range, and if row of j equals to 1, we have to increment. So height of j plus or equal to 1, else we have to set that to 0. So j equals to 0, right? So this is processing height, and now we have to process width. So first left, right? So for I in range, again this should be n, and as we said saw on the notepad, if row of I equal to 1, then we have to update the left of I is equal to max of left of I and current left, right? Okay, and else this will be left of I will become 0, and we have to update the current left plus 1. So equal to I plus 1, right? So now right, we need to start from the backward, right? So for I in range, we have to start from n minus 1 till run till minus 1 and decrement by minus 1. So if row of I again equal to 1, right of I is equal to min of right of I and current right, and else this should right of I will become n and current right becomes I. There is no increment by 1, right? So now we have to find area. So for again I in range, in the range of n, and max area is equal to max of max area and height of I computed by right of I minus left of I, right? So yeah, so now we have to come out of all the loops and return max area. Okay, I think we have to define maximum area, right? Yeah, I forgot, my bad. Let us go ahead and submit this. And as you can see, this is very efficient. Thank you.